Hey guys, now that we have a fairly thorough understanding of the human population, we're going to explore how that population interacts with planet Earth. Specifically, in order to understand those interactions, we have to understand the resources that we utilize and ultimately the resources that we have to manage. Defining a resource is fairly straightforward. It's anything obtained from the environment that meets our needs and wants. Yeah, so it's beyond survival. We certainly use resources today not only to survive, but to actually thrive. Some of these resources are pretty easy to access. Water, for example. Others, on the other hand, require some technological ingenuity to access them and to use them. We can categorize our resources that we use based on the rates of regeneration or replenishment. And with these three categories, we have perpetual resources. Perpetual resources are theoretically inexhaustible. Solar energy, for example. Our sun is about 6 billion years in age, and it has another good 6 billion years to go before the nuclear fuel runs out. We're not in any danger or jeopardy of running out of solar energy. Other perpetual resources would include wind energy. The Earth is not heated evenly. That unequal heat distribution creates differences in atmospheric pressure, and that creates winds. We can't exhaust our wind energy. Renewable resources. A renewable resource is anything that can be replenished fairly rapidly. Rapidly as in within minutes, within days, or within years. A replenishment or regeneration time that exists that is useful to humans, that is useful to the human timescale, that is. Examples include forests, grasslands, wild animals, fresh water, fresh air, and topsoil. We can become complacent when we think about using renewables. We can perceive them as being inexhaustible. However, they are. We only have to think of extinction with wild animals. In fact, we have to use them wisely, responsively, and we have to manage them scientifically. One way we do this is by determining, through mathematical models, a sustainable yield. For example, how can we keep a forest ecosystem intact when we harvest trees? For every tree that we harvest, we can plant another, for example. How can we harvest fish from the ocean while ensuring those fish stocks are reproductively viable for future generations? Scientists have established what we call a sustainable yield, which is the highest rate at which we can use a renewable resource indefinitely without reducing its available supply. There is no sustainable yield for what we call non-renewable resources. Non-renewable resources exist in a fixed stock or quantity, oftentimes in Earth's crust. They cannot be renewed on a human timescale. Yes, it's true that coal formation is a process, but it takes a minimum of 300 million years. This is a time frame that is not useful to us. The moment we start using it is when we start losing it. Energy resources like fossil fuels, such as coal, oil, and natural gas, have a finite amount. Other resources like metallic mineral resources like iron, aluminum, or non-metallic, salt, clay, and sand, are also considered non-renewable. With metallic and non-metallic mineral resources, we can reuse them. We can recycle them. With energy, we cannot. Energy cannot be created nor destroyed, according to the first law of thermodynamics, and therefore it cannot be recycled. Our next screencast, we're going to explore man's relationship with these resources and how it has changed over time.